Answer choice A. The average winter temperature in Florida is 7 and 5,500 degrees hotter than the average winter temperature in Minnesota. So if something's getting hotter, that means we would add it. So what we're going to do is we're going to take the winter temperature of Minnesota and add 7.55, and we should get Florida if this answer is right. So we're going to take the winter temperature in Minnesota, which is 13.47. We're going to add the 7 and 5,500ths. Answer choice A. The average winter temperature in Florida is 7 and 5,500 degrees hotter than the average winter temperature in Minnesota. So if something's getting hotter, that means we would add it. So what we're going to do is we're going to take the winter temperature of Minnesota and add 7.55, and we should get Florida if this answer is right. So we're going to take the winter temperature in Minnesota, which is 13.47. We're going to add the 7 and 5,500ths. And if this answer choice is correct, it should come out to the Minnesota messed up. And it should come out to the average winter temperature in Florida, which is 59.2. So 1 plus 4 is 5, plus 5 is 10. 1 plus 3 is 4, plus 7 is 11. And 1 plus 1 is 2. So those don't match up. So what that means is answer choice A is not going to be true. So what we look at is B. The average summer temperature in Minnesota is 36.68, colder than the average summer temperature in Florida. So now we're only looking at summer temperatures. So let's see if the difference between the two is 36.68. So what we can do is we can take 91.68 minus 67. So this is going to be 67 wholes, so we'd have to make sure we lined it up over here. 8 minus 0 is 8. 6 minus 0 is 6. We can't take away 7 from 1. 11 minus 7 is 4. And 8 minus 6 is 2. So the difference between the two is 24 and 68 hundredths, not 36 and 68 hundredths. So B would be wrong as well. Our next answer choice would be C. The average temperature in Florida is 85.76 degrees warmer in the summer than the winter. So now we're only looking at Florida. And it's saying that the difference between the two is 85.76. If we go ahead and solve it, 91 and 68 hundredths minus 59 and 2 tenths. Let's see what we get. Let's see if the difference is going to be 85.76. So this blank spot is just like a 0. 8 minus 0 is 8. 6 minus 2 is 4. We can't take away 9 from 1. 11 minus 9 is 2. 8 minus 5 is 3. So the difference between the summer and the winter in Florida is actually 32 and 48 hundredths degrees, not 85 and 76 hundredths. So C is wrong. And just because we've X'd out these three doesn't mean we're automatically going to circle D. We're still going to go ahead and see. So the average temperature in Minnesota is 53 and 53 hundredths cooler in the winter than the summer. So now we're only looking for Minnesota, and we're finding the difference between the two. So we have 67 minus 13 and 47 hundredths. Now notice how they're not lined up like this, because this is 67 wholes, which is the same as, let's say, $67, if that helps you visualize it, 67.00. So we can't take away 7 from 0, so we have to borrow. We can't borrow from the 0, so we have to borrow from the 7. 10 minus 7 is 3. 9 minus 4 is 5. 6 minus 3 is 3. And 6 minus 1 is 5. So the difference between the two is 53 and 53 hundredths, just like it's suggesting in answer choice D, which would be correct. Number 6, 20 of Erin's friends each agreed to donate $5 to her fundraiser. Which equation can be used to determine D, the amount of money Erin's friends donated to her fundraiser? So once again, we're going to look back at question 1. We're going to look back at question 4. We're looking at where that word each is. In this case, we have each right here in the information. And that's it. So look back on question 4. What does each in the information tell us? Each in the information is telling us that most likely it's going to be a multiplication problem. So right off the bat, we can cross off F and G. Now what we're left with is this. 20 of Erin's friends. Let's go ahead and draw it out. Here's a friend, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Here's Erin's 20 friends. Each of them donated $5. So this person donated $5, $5, $5, $5, $5, $5, and so on. So what we see here is we're going to take 5 and add it how many times? We're going to add it 20 times. And if we're adding the same number over and over and over, that is the same as multiplication. So we're taking 5 and multiplying it by 20, and we'll get the total amount of dollars, which would be answer choice H. Number 7. Wesley has 480 stamps in his collection. He puts these stamps into display cases. Each display case contains 15 stamps. How many display cases does Wesley need for his stamp collection? So once again, we're going to look back on question 1 and 4. If we have each in the info or information, it's going to be most likely multiplication. If it's in the question, most likely it's going to be division. Now in this problem, we're going to have each in the information, which would signal for us to do multiplication. Now, when we go ahead and multiply these numbers out, 480 times 15, when we multiply it out, we're going to get 7,200. Now, if we look at the answer choices, none of them are even anywhere near 7,200. So what I would do in this case is I would check my multiplication. Let's try it a different way. Let's try the box. 480 times 15. So we would get 4,000, 2,000, 800, and 400. When we add these up, once again, we're going to get 7,200. So we know our multiplication isn't the problem. I've tried it twice, and I've still got the same answer. Now, the big thing that I said was, most of the time, this will help you guide you in the right direction. Now, if you've tried it twice and it doesn't work, what else do you know each can mean? Each doesn't only mean multiplication, sometimes it can mean division. So since we've tried multiplication twice, we're going to go ahead and try the division. So we're going to do 480 divided by 15. And once again, we have to make our chart. So 30, 45, 60. So 15 can't go into 4. So 0 times 48 is between 45 and 60, which is 1, 2, 3 times. Drop the 0, and we have 30, which is 2 times. And we have nothing left. 32. And once again, we see that answer on here. 32. So the big takeaway is, each is in the information. I'm going to go ahead and follow the guidelines and multiply. Now, when I've double checked my multiplication and I still don't see it, I can go ahead and try division. And since I tried division and it worked out. At Lincoln Elementary School, the 5th graders have a total of 325 pets. Of these pets, 250 are some kind of pet other than cats. Which equation can be used to determine the number of pets that are cats? With this problem, it's not asking me to solve. It's asking me to find keywords or think about the problem in a different way that'll tell me what operation I'm supposed to be doing. So what we're going to do is we're going to use different numbers, simpler numbers, to help us visualize what we're doing. So let's say that at Lincoln Elementary School, the 5th grade students have a total of 5 pets. So there's 5 pets. 1, 2, 3, 4, 5. Of these pets, instead of 250, let's say 3 are some kind other than cats. So let's say this could be a dog, this could be a hamster, and this could be another dog. Which equation could be used to find the number of pets that are cats? So since these are something that aren't cats, we can take these away. So 5 minus 3, and we're left with these two being cats. So what we did was we took simpler numbers and just visualized what we're doing. So it doesn't matter that the 2 of these are cats. It matters that we determined to get to how many cats we have, we had to subtract. So we're going to take our 325. We're going to subtract the 250 that are not cats. And we would get 75. Now, once again, it's not asking us for the answer. It's asking us what operation we're doing, which is subtraction. So that would be answer choice G. Number 9. Last month, Jim drove his car 2,718 3/10 miles. That brought the car's total mileage to 87,416 miles. What was the car's total mileage before last month? We're going to look at it like this. Last month, he drove his car 2,718.3 miles. That brought the total to 87,416 miles. What was the car's total mileage before last month? So what we have to do is we have to take where we're at now, 87,416, and we have to take away what we just drove, which is 2,718.3 miles. Now, if you notice, they're not lined up, and I almost made this mistake too. So we have to make sure that all of our numbers are lined up. So this is the ones place, this is the tens place, hundreds, thousands, 10,000s. So this blank spot is going to be the same as a 0. We can't take away 3 from 0, so we have to borrow. We can't take away 8 from 5, so we have to borrow. Can't take away 1 from 0, so we have to borrow. Can't take away 7 from 3, so we have to borrow. 6 minus 2 is 4. And 8 minus 0 is 8. So 84,697 7/10, which is A.